When Windows NT was developed, there were certain goals that affected its architecture and its design. One of the goals was the room to grow, in other words, scalability. Another goal was portability to different platforms. Still another was compatibility with other operating systems and with legacy software. A supreme goal was security. In fact, Windows NT, one of the main reasons for the design of Windows NT was for increased security. Performance and reliability was a concern. And in regards to performance and reliability, one of the goals was to be able to isolate one process from another so that a change in one process would have the least possible effect on the other processes. So this was all accomplished by the architecture. Windows NT architecture is divided into two modes: user mode and kernel mode. User mode is also called non-privileged processor mode. The programs have only limited access to the system information, and they can only access hardware through other operating system services. Kernel mode is privileged processor mode. The programs have extensive access to the system and to the information and hardware. In the kernel mode are all of the services and drivers that keep the operating system up and running. The purpose of the kernel mode, its prime directive, is to keep the operating system functioning. Subsystems feed the user mode. So users using applications will get resources from the operating system through the subsystems. However, if an application begins to fail, the kernel mode will do all it can to bring that application back and keep it from failing. But if it continues to fail, the kernel mode will let it fail and will make sure that the operating system stays up. In other words, the kernel mode will not allow an application in the user mode to cause the operating system to crash. If we do crash the operating system, which everyone who's used Windows NT for any period of time has seen, called a blue screen of death, that means that something in kernel mode has stepped on something else that's in kernel mode, because it's impossible for a user mode application to cause the kernel mode to crash the operating system. As a matter of fact, if an application tries to crash the operating system, the kernel mode will cut off all resources to it and basically kill that application. Windows NT memory works differently than Windows 9X memory as well. Windows NT memory is perhaps the purest memory model developed so far. The Windows NT memory model uses a virtual memory manager, and the memory manager manages memory spaces. Each application is basically fooled into thinking that it has all of the memory that is available on the entire computer. So the Windows NT memory model is a tremendous advantage over the Windows 9X memory model. But remember, one of the goals was that Windows NT would also be able to run applications that were designed to run in a DOS environment or in a Windows 3.1 environment. This is accomplished by virtual DOS machines called NT VDMs, or NT Virtual DOS Machines. Using a virtual DOS machine, we can isolate an application from the rest of the system by providing a DOS-like environment to the application. Basically, what the computer does is it creates a little virtual computer that looks just like an old IBM PCXT. It's got exactly what DOS expected to see. The components of the NTVDM are the NTVDM.exe, NTIO, or input-output.sys, and NTDOS.sys, and then an instruction execution unit. Each NTVDM operates separately, so that if we have an application on one NTVDM and that application crashes, that will not affect in any way applications that are on other NTVDMs. So this is how Windows NT accomplishes the goals that were set for the operating system when it was developed. In our next section, we'll talk about how we can prepare a computer for a Windows NT installation.